Imagine the night sky in the 1960s: stars, the moon, and suddenly, a new moving light. It glides across the darkness, brighter than any plane, a man-made star. This was Echo 1, NASA's first communication satellite, a giant balloon as tall as a 10-story building. But Echo 1 wasn't high-tech, no electronics, no radios, just a massive, shiny sphere. Its job? To act as a giant mirror in space, bouncing radio signals from one side of the world to the other. Before Echo messages crawled through unreliable undersea cables that often broke. The idea of using space to connect the world was revolutionary. Project Echo was NASA's bold experiment to see if satellites could make global communication possible. The sight of Echo 1, visible to the naked eye, captured imaginations everywhere. It became a symbol of progress, a beacon of a new, connected age. For engineers, it was the result of years of dreaming and hard work. For the world, it was proof that the space age had truly begun. Echo 1 was more than a balloon. It was hope for a future where distance didn't matter. It showed that even the simplest ideas could change everything. The story of Echo 1 is the story of how a giant mirror in the sky brought the world closer together. And it all started with a shining dot moving silently overhead. Why a giant balloon in space? Because the old way, undersea cables, was slow, expensive, and fragile. Laying cables across oceans was risky. Sharks, anchors, and storms could snap them, cutting off communication for days. Radio waves seemed promising, but Earth's curve blocked signals from traveling far. Signals shot into space instead of following the planet's surface. Many doubted that bouncing radio waves off something in space would work. The idea sounded like science fiction. But NASA and Bell Labs needed a better way to connect the world. They imagined a simple, passive satellite, a giant, shiny balloon, as a low-cost test. If it worked, it could replace unreliable cables and make global communication fast and reliable. The challenge was clear. Could a floating mirror in space really bridge continents? The answer would change everything about how we talk to each other. And so, the race to build Echo began. Before building Echo, engineers needed proof their idea could work. Their first test? Bouncing a radio signal off the moon. In 1954, the U.S. Naval Research Laboratory sent Morse code beeps to the moon and waited. After 2.5 seconds, the beeps returned, faint but clear. This moon bounce proved that radio signals could survive a round trip through space. It showed the atmosphere wouldn't block the signal, and the concept was sound. If a rough, dusty moon could reflect a message, a smooth, shiny balloon would do even better. The success of the moon test gave engineers the confidence to build Echo. The dream of a man-made communications satellite was suddenly within reach. With the theory proven, it was time to build Echo 1. The satellite was a 100-foot wide mylar sphere, thinner than cellophane and coated with aluminum to make it shine. The entire balloon weighed just 136 pounds, astonishingly light for its size. Engineers assembled it from strips of mylar, sealed with special tape, working in giant hangars to avoid tears. The real challenge: fitting this massive balloon into a rocket. They folded it like space origami, packing it into a canister just 26 inches wide. The canister rode atop a Thor Delta rocket, launched from Cape Canaveral in August 1960. Once in orbit, the canister released the folded balloon into space. The next step was crucial: inflating the balloon to its full, perfect sphere. The entire process was a marvel of engineering and creativity. Echo 1 was ready for its moment in the sky. Now, it just needed to come to life. How do you inflate a balloon in space? NASA's answer: chemistry. Inside Echo were two small canisters of chemical powder, benzoic acid and anthraquinone. Sunlight heated the powders, turning them directly into gas, which filled the balloon. In just 16 minutes, the balloon expanded to its full size, a perfect, shining sphere. But space is full of tiny, fast-moving micrometeoroids that could puncture the thin mylar. If Echo relied on gas pressure, it would quickly deflate. The solution: once inflated, the mylar became rigid in the cold of space. Even after the gas leaked out, the balloon held its shape, staying a flawless mirror. This clever design made Echo tough and long-lasting. It was a self-inflating, self-supporting marvel. Echo was now ready to reflect signals and make history. The world's first space mirror was alive and shining. With Echo 1 in orbit, it was time for the ultimate test. On August 12, 1960, engineers in New Jersey aimed a giant antenna at the sky and sent a message from President Eisenhower. The signal bounced off Echo, traveling 1,000 miles to California. Through the static, the president's voice came through, clear and strong. For the first time, a voice message had crossed a continent via satellite. Echo 1 was so bright people everywhere watched it glide overhead. A man-made star. It was a shared global experience. Soon, music and the first transcontinental phone call followed. Echo proved that space could connect people instantly, across any distance. The world was witnessing the birth of satellite communication. A simple balloon had changed how we talk forever. The future had arrived, and it was shining in the night sky. Echo's success opened the door to a new era. Project Echo wasn't just about technology, it was about connection. During the Cold War, Echo became a bridge between rival nations. In 1963, scientists in the US and Soviet Union used Echo to exchange signals, despite political tensions. It was a rare moment of cooperation showing that space could unite rather than divide. Echo 2, launched in 1964, was even bigger and more reliable. Its polar orbit made it visible from almost every country, perfect for international experiments. Scientists in the UK, USSR, and beyond used Echo to test communications and study the atmosphere. Echo became a floating laboratory for the world. It helped refine satellite tracking and signal technology. The project proved that satellites could foster global collaboration. Echo's legacy was not just technical, it was diplomatic. A shiny balloon in space helped bring the world together. Echo's journey led to discoveries no one expected. Its lightweight, sensitive design let scientists track its orbit with incredible precision. Echo helped create better maps of Earth, refining our understanding of geography. Astronomers noticed its orbit was nudged by sunlight, solar radiation pressure. Studying this effect taught us about the solar wind and space weather. Echo became a tool for both communication and science. Its mylar skin inspired materials still used in spacecraft today. Echo proved that even simple ideas can have a massive impact. The project inspired a generation of engineers and scientists. Echo 1 and 2 burned up in the atmosphere, but their legacy lives on. They were the brightest man-made stars, symbols of optimism and ingenuity. Project Echo showed that space could connect, inspire, and unite us all. A giant mirror in the sky changed the world and reminded us what's possible.